Yes, hello, my good friends out there. I remain Dr. D.I. June, your lecturer on chemistry on social media. Our last lecture was calculations based on relative vapor density of gases. And I said that could be the last one I would take for that. So, right now, we are going into the last gas law we're supposed to know, and that is Graham's law of diffusion. Anybody here? Graham's law of diffusion. Now, the law states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. I take it again. Graham's law of diffusion states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. Now let us apply this mathematically. R stands for the rate of diffusion. So R is inversely proportional to the square root of the density of the gas. Or R is equal to K over the square root of the density, where K here is a constant. Now, from this equation, R stands for rate of diffusion of the gas, while the D stands for density of the gas. Now, assuming there are two gases to be talked about now, how shall we represent it mathematically? It now means that we said the rate of diffusion of a gas at constant temperature and pressure is inversely proportional to the square root of its density. So if there are not two gases now, it will now be that R1 over R2 will be equal to the square root of the density of what? D2, that is the second gas, over the D1, the first gas. So where R1 stands for what? Rate of diffusion of gas 1. R2 stands for what? Rate of diffusion of gas 2. The D1 stands for what? Density of gas 1. D2, density of gas 2. That's what this is talking about now. Now, when we come to the level of molecular masses of gases, we can also use this formula to apply. Now look at it now. R1 all over R2 is equal to the square root of M2 of over what? M1, where the M1 stands for what? Molecular mass of gas 1, while the M2 stands for molecular mass of what? Gas 2. Now note, this is very important now, note that rate of diffusion is reciprocal. In other words, it is inversely proportional of the time, because rate of diffusion goes with time. How many hours, how many seconds, how many minutes does the diffusion occur? So you must know that one. So the rate is what? Inversely proportional to the time taken. So that being the case, we now see that we can now represent it mathematically, that R, with rate of diffusion, is equal to what? 1 over T. 1 over T means inversely proportional to the time taken. Therefore, substituting that, so it means R1 is equal to 1 over T1, and R2, that is the second gas, will be now 1 over what? T2. If we substitute this in this equation, it means we will get R1 over R2 be equal to T2 over T1. So when we have done that, then we can now come back to follow the law, say inversely proportional to the square root. So since R1 over R2 is equal to the square root of M2 over M1, so it means that T2 over T1, which is we have here, is equal to what? M2 over what? M1. So the law is saying that the rate of diffusion of a gas at constant temperature and pressure is inversely proportional to the square root of its density. Because of time factor, as some of you may not be able to comprehend it, but we'll go into the calculations, you will understand it better. Please like it, follow me, comment, subscribe to my YouTube. Thank you.